Hi there, so last time we were looking at using the binomial distribution to help us find probabilities. Today we're looking at cumulative probabilities, where you've got to work out the probability of everything below. Say you wanted 5 or less of something, but you've got 20 altogether, and you can't just do 1 minus something, and it would take quite a while to do all of the different probabilities and add them all together. Is there a way we can do this all in one go using binomial? Oh yes, there is. There's the old way of doing it with the tables, which is absolutely fine in the exam. I'll very briefly show you that, but we'll mainly focus on how you can do it using the calculator, because that just makes life a whole load quicker and easier. Right, so here's our first example. We've got a random variable given as x, being the binomial, can be expressed with a binomial distribution of 20, where the probability of the event happening is 0.4. And we want to find, first of all, the probability that x is smaller than or equal to 7. Now, for all three of these different events, I'm going to show it to you, first of all, using the tables, and then I'll show you the calculator, and then for the rest of the video it'll just be the calculator. And if you want to use the tables, then you'll just need to check your answers. The answers will always be the same, and normally we work to 3 significant figures in A-level maths, don't we? But because these tables, if you see them here, it's page 29, by the way, in the book of tables that you get in the exam. Binomial cumulative distribution function, that's what it's called. And you've got a whole load of different tables. It goes on for 3 different pages, and in the left hand edge you can see it says n equals 5, x equals 0. So that means the number of trials would be 5, and that's the probability that it would be 0. Now the different probabilities you can have are along here. So in the exam, all of the probabilities that you get will always be one of these, so that it can be done with the tables. And the number of trials is always going to be somewhere between 5 to 10, and then it goes 12, 15, 20, 25 and 30. So it's going to be one of those number of trials that you get. So for the first one, we've got 20 trials and the probability is 0.4, and we want 7 or less. Now that's the easiest thing to do in here, because that's how it's set up. A little bit more thinking for the other two. So if I go to n equals 20, that's my number of trials, the probability is 0.4, so that's this column here that says 0.4. I read all the way down until I get to, I want 7 or less, so 7 across 0.4, 0.4159. So I'll just make a note of that, equals 0.4159. And so we would leave it, as I said, to 4 decimal places. Then, next up, it says probability that it's less than 6. Now the tables all include the probability of 1 or less and do it cumulatively like that. So what we need to say is that that's going to be the same thing, because we have whole numbers of trials. It's discrete, it's not random, it's not continuous data, is it? So it would be less than or equal to 5, because we just want 1, 2, 3, 4, 5, the number of times it can happen. So if I go back to here, now, still in the 0.4 column, this time 5 goes across there to 0.1256. Now, the last one is going to make us think a bit more. We want more than or equal to 15, and the tables do a countdown. So we've got to think about a bit like if you know the probability of getting 1/6 is 1/6, the probability of not getting a sixth is 1 take 1/6 is 5/6, isn't it? So we're going to say the probability of that is going to equal 1 take the probability that Well, that's greater than or equal to 14, so we want 15, so we want less than that. So less than that is going to be 14 or smaller, so 0 all the way up to 14. So I'm going to say one take, then I'm going to look in my tables again, and it was that column there, wasn't it? I get 0.9984. 0.9984. Take that away from 1 gives me my actual answer 0.0016. Right, so how could we have done it in the calculator? So here's the calculator, and we start off by getting to binomial. So hopefully you remember how to do that. If not, we go, we want our menu, don't we? We want statistics. We want distribution. We want it binomial. And you don't want the Poisson distribution, you want the cumulative one, BCD for cumulative. And that gives us this. Now, the lower that we want, because we want it from 7 or less, the lowest that we want is 0 results. The upper that we want is 7. The number of trials that we're doing is 20. And our probability is 0.4. Oh, 0.4. Press execute there, and I get 0. It's actually got it a bit more accurate than the tables, but I would round that to 4 decimal places and I would still get 0.159, wouldn't I? Okay, so there's that. Then I want to do this one, so I press exit, go back to here. This time I want it between 0 to 5, don't I? I still have to do that same process, by the way, of thinking, right, I want it adding up to or equal to that. So the upper result that I want is 5. Then I just press equals twice, 0.1256 to 4 decimal places. But where it really gets easier than the process we had to do here is, if I go back by pressing exit, all I have to do is say where I want it from to. So I want it, my lowest possible amount is 15. Oops. So that's my lower part. I'm going up to 20. My number of trials is 20, my probability is 20, and it gives me 1.6115 times 10 to the negative 0.3, which is 0.0016 to 4 decimal places. And that's that. Okay, let's have another look at some more. Okay, hopefully you know enough now to pause the video and give this question a go. Now we want the largest value of k so that the probability is less than that. So we're going to have to do a little bit of trial and error here. So if we start off by just picking an amount, it's 0.4 chance of happening. So the chance that it's going to happen is pretty likely over 50 trials, isn't it? So we want the number so that it's smaller than that is going to be it. So what might that be? We just need to pick a value. And off the top of my head, I really don't know. So I'm just going to go with 10 and see where that gets me. So I'm going to go with x being smaller than or equal to 10, and I'm going to find out what that is. So into the calculator, and we just change all of our data so that our lower value is 0 and the higher value is 10, but the number of trials is 50 and the probability is still 0.4. Oh. So that's giving me 0.00 to the negative 3, so that is 0.002197. Now that is way too small, isn't it? I want 5%, so all I'm going to do is up it a bit, so that means that we need to have a few more than that, don't we? So maybe let's try 20 and see if that's too far. 20, 0.56. Ooh. So actually I could say, right, that's smaller than 0.05, that's way bigger than 0.05. So I've pinned it as somewhere between the two. So now I'm going to go, well, it was closer to 10, so let's try 14. And that, oh, that's close, 0.0539, 0.0539 is 40. Now that's still a little bigger than 0.05. So I've got a real big feeling about 13 being the number that I want. So we go 13, and it's 0.02798. 0.279. So that is 80, isn't it? And that is smaller than 0.05. So the largest value that it's going to be will be k being 13. Now you need to think of something of a similar sort of process for the smallest number r, such that x is bigger than that. So again, pause the video now that you've seen what's going on there and see if you can do this one. So I went through this table of values starting with 14 and 30, and I got it down to between these ones here, where this is too small, that's bigger than. Now we want it smaller, so we want it like this, but we want the smallest number of r where it's not or equals to. So if we had 29, it would be smaller than. If we had or equals to 28, it's going to be 28 that we want, isn't it? Because we want the smallest number that make it have that. Now that's or equals to, which means that 28 is our number. Hope that makes sense. And that's because it's saying that it's bigger than. 28 is not acceptable, 29 is, but because r is going to be smaller than that, that's the first number that is smaller than it is, that is acceptable, if that makes sense. So r is 28, because 28 is not actually valid, but it's the smallest one, it's the biggest one that doesn't work. 29 does work. Okay, here's our next question. Pause the video, write it down, have a go. Right, we haven't talked about the assumptions today. It's just like it was on the previous lesson when I introduced the binomial distribution. So we're going to be able to use a binomial. So, and it's 10 trials, and the probability is 0.3, isn't it? So that's what you'd write first of all. That's your suitable distribution. And your necessary assumptions, that there are exactly two values it can take, either people listening or not listening. So two values possible, listening or not. Then you could also have a fixed number of trials, couldn't you? You could have the fact that the probability is always fixed, it's always 0.3, and that each resident is going to be independent of the others. Is that true really about listening to radio? Don't know, but that's the assumption that you're making. Okay, next up, the probability that at least half of these 10 residents listen to local radio. So half of them. So we've got 10 there. So if it's, what we're saying is the probability that x is going to be at least half, or 5 is half, isn't it? So it's 5 or more. So getting a calculator, you're saying, right, the smallest we can accept is 5, the most we can accept is 10, the number of trials is 10, the probability is 0.3, and that's giving us 0.15026, so 0.15003. Find the smallest value of s so that the probability of x happening is greater than or smaller than s. So we need to, and that the smallest value, that gives us a probability of less than 1%. So again, it's a little bit of trial and error. So go for it however you want to do it. You're about to see my results the way that I get there. Right, so I did quite a good first guess. I went for 8. I knew it had to be more than 5 because 5 was 15% and I only wanted 1. I got a little bit too less. I then had a brain fade and went for 9, which was even less likely. So when I looked at the questioning, I thought, no, that's not what I want. I've got to check 7. And when I checked 7, it came in at just over 1%. So 7 was not acceptable. So the smallest value that is acceptable is s being 8. Right, here's the last question for today. So really make sure that you've given this the best go you can before you watch me talk through what you could have done. So part A, you should have 0.2794. So I started off by putting down my distribution, 50 trials, 5% chance. And then I said, right, less than 2 means it's got to be 1 or less, so 0 or 1. And then in the calculator, I've just gone for a lower of 0, upper of 1, number of trials 50, probability 0.05. B coming up in a moment. So here's part B. I thought about the fact that more than 5 is equal to or more than 6, and so I put in my values as low as 6 and upper 50. Okay, in a moment I'll go through part C. Right, and D was 5, which is basically what we had the time before. So the probability that it was greater than 5 was the same as being or equal to 6, and that gave us 3.8%, didn't it, which is less than 5%, so I've just identified that. Then I've tried out probability of 4. You might be able to just notice under there that for a moment again I went the wrong way for 7, then I realised before I put it into the calculator that is the wrong way. I want the smallest value of D, so we've already worked out that 5 works. So we went down to the next one, and that was too much, which is not acceptable. Hang on, I've just realised I haven't shown this properly because I've done greater than or equal to 4. I haven't done greater than or equal to 5, so I should really show that one. If we did that, popping that in there, lower value would be 5, equals, check that, yeah, that comes out as 0.103, which is 10%, isn't it? So that's not acceptable either. So it definitely is D equals 5. Don't know why I forgot that value for a moment. Anyway, hopefully that all made some sense. We will be moving on again next time in towards the whole idea of hypothesis testing, which is taking these ideas but where we're coming up with things on how we decide how to test. So why do they pick on those numbers as 5%, things like that? What's that all about? That's what we'll be discussing.